Welcome to 8 things that happen at the dot. This is going to be attribute access and descriptors. I'm Andy Fundinger. A little bit, who am I? I'm a new father this year. Thank you. I've been a Python developer since version 2.4. My first Python books were Learning Python version 2.2, newly updated for version 2.3, and with a little section about what was coming in 2.4. This talk, on the other hand, is all Python 3, but oddly enough, most of this stuff is exactly what was introduced in Python 2.2, with one exception. I've previously approached the use of descriptors in a talk on typing for PyCaribbean 2016. That's on the web, you can look it up. I've worked in industrial automation, metaverse development, and the financial industry. Currently, I'm at Bloomberg, working in the data license group, and what we do is deliver financial information to clients. It's a very diverse environment. We use Flask, Celery, PyCSVW, Jena, Riot, PHP, Perl, JavaScript, C, C++, Java, and who knows what else is running around there. It's an interesting environment because it's enterprise scale, but things move very quickly. Quick slide about Bloomberg. We have a number of different products. The terminal that's been out here, in trading systems, the enterprise data, news media, Bloomberg Television, Bloomberg Radio, some specialty products for energy, finance, and government. It's actually a fairly substantial endeavor. There are 5,000 engineers, 150 in machine learning, one of the largest private networks in the world, and a lot of data flowing through it. Let's go ahead then and consider our friend the humble dot. Normally we have the dot, and it's just sitting there between the O and the X when we access an attribute off one of our instances, and it's just syntactic sugar instead of calling getAttr O of X. And even in the simpler case, it's just going into dunderdict and pulling up X and returning that. Of course, maybe it's not. Maybe it didn't find anything there, and it goes off to the class and goes to the class's dunderdict and finds Y is there and returns that. Or maybe it's not there either, and we start to go into inheritance, and we go off to the base classes and go find from their dunderdict and return that. But this is Python, and we have a little bit more magic going on. We can write the getAttr function, and the getAttr magic method will go ahead and say, well, I didn't find it in dunderdict. I'm going to go call getAttr and see what it gives me, and I'll return that. So our probe class here is doing just that. And we can see that before we set a value for R, we actually call getAttr. After we set a value for R, getAttr is no longer called. If we go over to the other side of the equal sign, and we define setAttr, it works about the same for setting values. Going even further, this is what was actually introduced in Python 2.2, the getAttribute magic method, which is actually what calls getAttr. So object getAttribute will be called every time you access an attribute, whether it's in dunderdict or not. And here we can see, we go ahead, we call it before, we call it after. In both cases, we get any var back. But object getAttribute is actually doing a lot more. Let's take a look at this. We'll define a class called probeND. ProbeND has one method, it's called dunderGet. And dunderGet just puts together a string and returns it so we can see what happened. Then we'll go ahead, create an instance of my object. And I'm not even going to redefine my object. I'm just putting one instance of probeND into the class dict of my object. Then when I call O.z, accessing that attribute, it's going ahead and calling the get method on the probeND instance that's in the dict of my object. And we can see we have a similar behavior to getAttr. Once we've put something into dunderDict, which I've just done directly for illustration, we get that back. Get on our probe ND is not called again. But there's still more going on because getAttribute is actually looking to see what the thing that it found in the class dict was. Beyond just having a get method, if there's a set method there, then the behavior changes. So here probe DD adds to probe ND a set method. And we can see that here, even though we put a value into the instance dictionary, we're still getting our get method called. It's the same get method, but the fact that the set method there is changing the behavior. Just for completeness, if we do add a set method, just for completeness, that set method is called when we access on the left side. So if we set a value for O.z, we can see that that set method is called, and set is telling us that something was set. Of course, that set method is not assigning any value into the instance dictionary or doing anything but throwing the value away. So the dictionary remains the same and the behavior remains the same. So here then we have the 8 things that I promised. Here are the 8 things that happen, or you could probably list these a few different ways. The first 3 are our basic search. Check the instance, check the class dict, check the base class dict. The next 3, 4 through 6, are our magic methods: getAttr, setAttr, and getAttribute. 7 and 8, however, are the descriptor protocol. These are actually saying it is relevant what the object found in the class dict is and what methods are on that. So here then is the descriptor protocol. It's 3 methods and one that just came in 3.6. This is the only change since 2.2. dunderGet, dunderSet, dunderDelete for all those times that we actually delete our instance attributes. I can't remember having done that, but surely someone has recently. And set name is a wonderful addition because before this, those descriptors had no way to find out what class they had been attached to and what attribute they had been put on in that class, which led to things like a class decorator or a meta class to just go and check back over the descriptors and tell them that vital information so they knew where to store the data when they're doing a set. If you just have get, so looking at this though, if you just have get, you have a non-data descriptor. That's what the ND was for. And if you have get and set, then you have what's called a data descriptor. Wonderful, we have terms for things. That's always useful, but what can we do with it? Well, the big thing here is method binding. The only way instance methods work at all is because of the descriptor protocol. So let's take a look at this. We'll create just a really basic class. Greeter, it's got one function, it's called greeting. Greeting says hi. Okay. After we declare this, we'll check what the class is of greeting. The class of greeting is a function. In Python 2, it was an unbound method. But that function object has and always has a dunderGet on it. So this is in fact a non-data descriptor, and we can see it there. When we instantiate greeter, access.greeting, and get back our bound method and check the class of that, it has changed. And it has changed because it accessed that object in the class dict and it got a method object back. And the difference here is that the method object is bound to that instance, so we can then call it. Okay, so what else? If it's just an internal, not so exciting. So obviously, if this is used for normal method bindings, it's also used for the variant method bindings. Interestingly enough, they came in at the same time. You have your static methods, your class methods, and your properties. These are all functioning by making a different descriptor that binds functions in a slightly different way to make it all work together. Framework tricks. How does SQL Alchemy do queries when you start accessing properties off your instances? Well, it's because those are actually descriptors, and the descriptors will actually trigger off code when you do gets and sets, and that will all process through. It's in Flask config. It's in any number of your frameworks will have this. It's also the way that if you start to write a lazy execution setup, you're likely to hit this, or if you're proxying something. You might insert a descriptor for monitoring so you can see every time someone accesses data as it goes through your system. Runtime type checking, like traits, is using and relying on these descriptors to make it work. Let's pull an example here. Our first example, let's say that we want to have two names for one attribute. So this is an alias descriptor. You might use this, as I'm showing here, because you're renaming the attribute and you just need the data stored only once, but some code's going to use the old, some code's going to use the new. You're not quite ready to deal with the ramifications of that. So when we construct it, we just tell it what the other name is. It doesn't need to know what its own name is. That's fine. Anytime you do a get or a set, it's going to go and do a get adder on the other name, pick up what it finds, or set what it's been told to set. One thing I will point out here, you can, if you access it at the class level, you will get a get call, but the instance will be none. So you can see here that when someone does that, I'm returning the descriptor itself, so you can still get at it. Over on the right, I've gone ahead, I've defined a data class. That data class has the old names, legacy X, legacy Y, legacy Z, and the new names, data X, data Y, data Z. And those are just aliases over. So we can see as we actually execute this, we'll create an instance of the data class. We'll give it X, Y, and Z as hi PyGotham 2017. And we can see data X and legacy X are both high. PyGotham is coming off of legacy Y. And data Z and legacy Z are identical by the is identity. If we change just data X and go ahead and print this out again, we've changed both data X and legacy X. So we get hello, hello, PyGotham. This time I'm pulling PyGotham off of data Y. And that identity on the end is still true. So let's take another one. I told you we could play games with function binding. Let's play a game with function binding. You know, class methods work a certain way, but another way they could have worked would have been if you called a class method and you didn't have an instance, it would just create one for you. I'm not sure I would use that behavior, but it makes a good example. So I've created something, I am calling it a defaulted method. It's both a decorator and a descriptor because that sort of binding thing, that's how we're used to it. So when we construct this, we just capture the original function, store it away. Whenever we get it, we check to see if we were given an instance or not. If we were not given an instance, then we create an instance of the class. And in this case, I'm doing the binding with a partial call. Now that's just for example. I thought that might be a little bit easier. On the next line, I'm doing the binding in the totally normal way with the function's own get method, which is the way you'd do this in a real case. So let's go ahead and see how this works. We've got our name printer on the right-hand side. It has a constructor, it's got a default name, and it's got two methods, name print and print name. They are both exactly the same, except one is a defaulted method, print name is defaulted. So if we construct this and we give it my name, we have our name printer Andy, we print name and we name print, we get back Andy Andy. If we go ahead and just call it off the class, name printer print name will give us the default name. Name printer name print will give us back our familiar type error because we just called an instance method without giving it an instance. So I'm going to go ahead and take questions here. Do we have questions? One question that came up when I gave this internally is which should I use and when? So first, big star here is when you're doing normal things, do it the normal way. It's completeness on the table. If you're doing something like caching or lazy execution, it's likely that your first thing to reach for is going to be the getAttr magic method. That's because once you call that, once you set a value, once you acquire a value in any particular way, that value will be set there and automatically used by Python. Your code isn't going to be run again. If you're doing something like a proxy to a remote, presumably unknown API, every time you access me, I'm going to make an HTTP call. I don't know what's valid. I'll throw an error then. Then you're going to want to do something with getAttribute because you have no idea what's valid. Just pass it all through and throw your errors as they fall. Your non-data descriptors, where you're only using dunderGit, those do tend to be method binding because a set to a method doesn't tend to make sense until you get to a property where it does. On the other hand, your data descriptors, where you're implementing both get and set, those are something like runtime typing, data binding, any sort of tool like that tends to go through a data descriptor. Okay. Other questions? Yes?
So, I have a pull request to see Python update the descriptor of how to and that's what data descriptor is. So data descriptor would also have maybe a set or release.
Uh-huh. Okay, so what's the change, or is it just a change in documentation?
So it's a change in documentation, not change in behavior. Just updating the documentation to better express exactly what the descriptor is. A data descriptor has either has a set or delete.
Oh, okay.
And it'll usually have both, and it'll usually have a yes.
Okay. Okay. Yeah, I haven't used delete in a class for so long. I have to at some point research who uses that in current code. It's a great idea. It's just other questions, if any. Yes.
Why is the addition of the set of the dunder set change behavior from just having just the single dunder get?
That, why does it change the behavior? Basically, we need both behaviors. You need the behavior for a complete override, and you also need the behavior for like a class level default. So since that would be the behavior for a class level default, once you do a set, having no code for set, you've overridden set. So now It's in the instance dictionary. The fact that the instance dictionary is skipped entirely when they're both there is basically because we needed that behavior and it was a good way to signal it. There may be some deeper reasoning, consult the core team, but that's how I understand it. Other questions? Okay. So I'll just note, this is kind of a deep magic function of Python. These will do weird things. These will do unintuitive things. These will leave you with code that doesn't do anything much like what the code looks like it does until you start digging into it. So be careful. Use this only deliberately, and especially use it to dig yourself out of holes. Because if you're using these and you dig yourself into a hole, you'll be out of shovels to dig yourself back out of the hole, and you'll be at the bottom of a hole. So do be very careful on the use of especially the descriptors. I'm going to be over at the Bloomberg booth after this, and probably through the next break. Do we still have time for if someone's got a question at this point? Okay, you've got your last chance. Okay, thank you.